Hi everybody, welcome back. This is example 9 on homework 10.3. We're going through conservation of momentum problems. And the assumption here in all these problems, and every single one that we're doing in this homework section, is that the net momentum initial of the object or the system or series of objects is going to be equal to the net momentum final. Okay, so whatever initial momentum the system has, the same total momentum for the whole system will be finally. Okay, so here we have a 12,500 kilogram railroad car. All right, so let's just go ahead and write that down. Mass of the car. In fact, I'm going to say mass. Well, there's only one object really. Mass initial is 12,500 kilograms. Now, that might sound kind of funny because usually when we think of initial and final things, we think of things like velocity with which changes. Well, this railroad car, it's traveling by itself on a frictionless track, but then the mass is increased. A 5,750 kilogram load is dropped onto the car. So the mass is actually changing. So we can say that the final mass, M final, is what would that be? That would be 18,250, right? If I add that to 12,000, yep, 18,250 kilograms. If we add 5,750 to that 12,500, okay, so that's a final that's a final mass of the car. So the mass itself is actually changing. Okay, so we want to find out what is the car's final speed. All right, well, the initial speed of the car is 18.0 meters per second. All right, 18.0 meters per second. The final speed is what we want to solve for. Okay, that's a question mark right there. So again, like we said before, the net initial momentum is going to be equal to the net final momentum. Okay, so the initial momentum is the mass initial times initial velocity. And that's going to be equal to mass final times the final velocity. And that final velocity, that's right here, is what we want to solve for. So we're going to divide down the mass final down below the mass initial times initial velocity. So M initial V initial divided by mass final equals final velocity of the car. So let's find out what that actually is. So it had a certain amount of momentum. The mass changed, and so what should happen is that the velocity should change correspondingly. Okay, so what is mass 1? 12,500, right? 12,500 kilograms times the initial velocity, which was 18.0 meters per second. Take that and divide that by the final, the final mass, which is 18,250 kilograms. I think I did my math right. I added 5,750 and 12,500. I think I had that right. I added that together in my head as the total combined mass of the car and of the additional load. So what's the final velocity of the car? 12,500 times 18 divided by 18,250. That is 12.3 meters per second. It's our final velocity. Now the car is going in the same direction. It hasn't changed direction. It hasn't hit anything else. But the initial velocity was 18 meters per second. Now it's cut down to 12.3 meters per second because the mass increased, which means the velocity has to decrease in order for momentum to stay the same or be conserved before and after that event, that collision right there. All right, that's example 9 on homework 10.3, conservation of linear momentum. Thanks for following along. I'll see you on the next one.